example. So wherever we don't require contact between the objects, that's called non-contact force, right? Again, I make it very clear that contact is not necessary. Even without contact, that force can act, right? So that's a non-contact force. If I'm standing on ground, gravitation is acting on me. So is that a contact force or non-contact force?
The non-contact force.
The non-contact force.
So I'm standing on ground and gravitational force due to ground is acting on me. Contact or non-contact?
Non-contact.
Non-contact, sir.
Non-contact. Because even though I am standing on ground, the gravitational force would be acting even if I'm not in contact. So that's why it is contact. Same, nuclear force is an example of contact force. Gravitational force is an example of contact force. Then we have magnetic force. All contact, non-contact forces are also known as field force. Right? Then what does the force do? What does the force do?
Sir?
What does the force do? If I apply force to a body, what would happen? Yes,
Sir, it would move.
if we
So
apply
it can
force on a
change
body,
the shape of an object.
It can change the shape, size, and direction of a body.
so one thing that it can do is it can change the shape of the object. When it is changing
Sir,
shape
it
of the
can
object,
change the direction of an object. It
It
can
can-
speed up a moving object, or it can stop a moving object, or it can change, or it can bend an object, and it can also change the position of an object.
what all things can it change? It can change shape, size,
Direction,
position.
direction.
I'll put both together, direction and speed, right? So both together we call it as velocity. Both direction and speed together we can call it as velocity.
Velocity.
So these are the things that a force can change. Now, so anyhow, we're not going to discuss much about this, but because we're only bothered about this part. If velocity changes, what does it imply? What is it? Change in velocity by time. What is change in velocity by time? This is acceleration. We have defined. So how do I define it? I can say acceleration equal to how much? Change in velocity by time. Fine. So otherwise, what I can say, if these things are, if shape is constant, size is constant, then I can say a force applied on a body would imply acceleration. So if I'm taking a point object, if it is a point object, what is a point object? If I consider a point object, what is a point object? Yes, anyone? What is a point object?
Which is like a simple dot. I actually don't know. I'm just guessing. It's like a simple
It
dot.
doesn't have any dimensions.
Yeah, Naisha, what is this point object?
It doesn't have any dimensions.
It doesn't have any dimensions. Okay, fine. In physics, when we discuss in physics, what might be point object? Any other definition of a point object? Why others are very silent today? It's just a point. Okay, that's a good way. Shamik, Ishan, we have two Kartiks. Both the Kartiks are same or two different people? Shashwat, yes, you want to say something? Shashwat, what is a point object? Like say a lot of you typing something like a dot. Fine, dot, point, everything is considered Naisha. Anything apart from that? Kirtana. Shashwat, can you mute yourself if you're not answering in the class?
I'm Shashwat from.
Only motion is considered. Shamik, any answer from you? Kavya, Varnika?
Sir, can the dot be of different sizes?
So for that, we need to define what is the point object. Okay. See, in physics, at least for our level, so class 8, 9, whatever we discuss, we say a point object is an object whose dimensions are very small compared to the displacement of the object. So it depends on that. It's a relative term. Now, so in that case, what happens is, like I'm talking about like a bus traveling for 40 kilometers. So then what happens? The bus becomes a point object. You're getting it, because when you compare the length of a bus, which might be around 20 meters, with respect to 40 kilometers, it's a very small distance. So bus becomes a point object. We can even say a train traveling for 1,000 kilometers. So I can consider even the train to be a point object, right? And when you're talking about, let's say, the whole solar system and the motion of Earth around Sun, the Earth itself is considered to be a point object. I hope you understand this. So
Yes,
what is the
sir.
point? Yeah, what is the point object? Point object is an object whose dimensions are very small compared to the displacement. Whenever the dimensions of the object are very small compared to the displacement, we call it as point object. So Naisha, your point can be as big as a bus or as big as an Earth, or as small as maybe a small dot put by a pen. Fine. All of you got it? It's a relative term. So when I talk about point object, I'm not really bothered about shape, size, and position of the object. I'm only bothered about the velocity. So what happens whenever force acts on a body? There is an acceleration imparted. That means what? There is a change in velocity that the body undergoes. After that, so what I can say now, based on this, we have now the other things. For we have three laws. What does the first law say? Newton gave us three laws of force. So we call them as laws of motion. So what does Newton's first law say? Yeah, quickly, can you tell me what does Newton's first law say?
An object that's in motion stays in motion, and an object at rest stays in rest. I mean, stays at
So
rest.
yeah, we'll only discuss about the importance of the first law. What is or the actual meaning of the first law? We are not really looking into the statement now. So what does it say? It says that if force is not applied, what is happening? Acceleration. So if force is not applied, what will be the acceleration of the body? Acceleration is 0. So what does acceleration is 0 means? If the body is at rest, it will continue to be at rest. Body at rest continues to be active. This is the first point. And the second point is what? If the body is having some velocity, some k meter per second, it will continue to move with same meter per second. So what does it mean? Body with uniform motion continues to have uniform motion. This is what is the meaning of uniform motion, right? The first law. Of course, we call it as law of inertia also. And what is inertia? So this law is also known as law of inertia because any system in the universe opposes change, and this opposition to change is known as inertia. We discussed that, right? And after that, this is first law. And what is after? So first law talks about a situation where force is not applied. And second law, what does second law say? What happens if force is applied? If force is not equal to 0, what does that imply? Acceleration is not equal to 0. So from this, what I can write? And this is one condition. And the second condition that we get is force is proportional to A or force equal to mass into acceleration, right? This is what is the second law. But there is a condition if mass is constant. If mass is constant, what is force given by? Force is given by mass into acceleration, right? And then we had third law. What does third law say? Can anyone help me with third law?
So every action has an opposite reaction.
So what does third law say? Third law says every action
has an equal and opposite reaction.
Has an equal and opposite reaction.
Every action has equal and
opposite reaction.
Opposite reaction. That's what is third law. So, and what is the second point? I'll say action has equal and opposite reaction. I'll just write it. Now, what is the second point? The other thing that is important is action is. Arya, can you mute yourself? Yeah. So every action.
Hello, sir.
Can you mute yourself? Fine. So what I can say, every action has equal and opposite reaction, and action and reaction always act on different bodies.
Excuse me, sir.
Yes.
Sir, this third law can be applicable to friction.
Every law is applicable everywhere. Only there are very few cases where we cannot use it. So every law, more or less, I can say it is universally applicable.
Every action has a opposite reaction, opposite and equal reaction. For example, when you throw a ball onto a wall, it gives it back with the same amount of force.
Yeah, fine. So it is. See, not only this, I think so. Every action has equal and opposite reaction. Can be applied. There might be, unless and until we are talking about situation where there is relative acceleration, and you don't have to bother this. As of now, you can assume that all the three forces are existing everywhere in the universe. Right? So, a few more things that we would require to go ahead. So today's class will be focusing on pressure.